I will upload this to YouTube, to our channel. So everyone, we get to do some real coding today. I've tossed the link in. Let me head on over to what you're seeing at this point. I'm just quick saving our emails. So I'll share my screen. Let's have fun here today. You should see something like this. If you head on over to Colaboratory, does this look familiar? Is this something you see? So Jessica's there. James, all right.
Yeah, I can see it.
Excellent, Matthew. All right, so this is what we'll be working in. This is what we're going to do our magic with, the Colaboratory tools that are available online directly through Google. You don't pay for anything here. I encourage people just to use your student Gmail account. Comes with your LCC student package. And so we're going to actually work with some data. Now, first things first, see up here, file, new notebook. That's what we want. We want to start from scratch because we're going to, from scratch, we're going to actually work up to doing some pretty, what I think are amazing things in just very basic amounts of code. So first things first, notice we can add code or text. And we can slide things around. So I like to normally intermix. I like to have some code, some text where I essentially put in some markdown to keep track of what's going on. That said, today we're pressed on time, and I'm, don't tell your programming professors, but I'm not going to do a whole lot of documentation today. We're going to do just the bare essentials. So see, I did add a text, and I'm going to put, if you've used Markdown before, I'm just going to quick say, maybe setting things up. So I put in an H1. That's Markdown in this case. I could have added 2 of the number signs to make it an H2 in terms of HTML. You can very quickly document what you're doing. I just did one quick example here, but let's actually import some stuff this is where the magic happens. We already have all these wonderful libraries that are available. So the first thing, I want to import pandas. I'm just hitting enter. At this point, I'm not running my code. I'm just hitting enter and moving to the next line. And I need other stuff too. Pandas makes it really nice for working with the data. Also PyPlot. I'm gonna use that and I'm gonna use it as PLT. We're going to use some tools to actually analyze the data. We're going to use what's called a decision tree classifier. And we might want to, I'm not sure we'll get to this, but we might want to see how we're doing in terms of what the analysis is actually showing us. So let's import the metrics. And finally, what I think is so cool. Actually, I'm going to come back here and I'll do it this way. You can actually see a visualization of the cool stuff we've done. Now I've got all this entered. If you're following along with me so far, just put a Y in the chat, just so I can make sure everyone is where I'm at. So Nick, Jake, all right. Anyone else? So Jessica, James, Billy, all right. Matt, all right. This is excellent. Oh, this is so fun. Honestly, this is now what I do when I'm done with a cell and I want to run it, I can just hit shift and enter. So shift and enter, and it runs that cell. And voila, it's run. Now, if you have a mistake in there, don't sweat it. I'm going to have tons of mistakes in this too. Just update it, see where you think the error is. Look at my particular code. See if you got a typo in there. Otherwise, if it worked correctly, it just moves you on to the next cell. Well, we need some data. And I already went out and I looked for some because I wanted something easy. Now, we won't always pick something so easy, but look, do you see, I've got a web page open here. This is through Stanford for one of their classes. And notice, oh, no problem, Nick, just hit shift and then enter. But actually, let me, before I touch on this, the other way to do it, if you have the cell below, if you want the manual method, you can just hit this play button if you haven't done so already. That will actually run that cell. And you can actually just use the tools at the bottom here to add a code or text cell. We usually are going to be adding code cells. And I'll show you a few more tricks as we go, but I just hit shift and enter to run the code in a cell and move to the next cell. So good question, Nick. Now, look, we've got this data set. It's over here. I could download it to my computer and then try and upload it into the cloud and then try and reference it in Colaboratory. I don't have to do that. No, watch. Notice I can right click over Titanic here and I can copy the link address. Now, I come back over here. I want this data. I'm just going to say URL equals, and I'm going to paste that in. That's it. It's honestly, it's incredible to me. What in the olden days, those of you, back in my day when we had to walk uphill both ways, I'd have to build a cumbersome Ajax library in JavaScript and set things down there, but I wouldn't actually handle all the possible error states. It would be a clumsy library. And then this all just happens automatically when we use this URL. I've got the URL. I'm going to create a data frame. And just so I keep it, I know which version of the data frame it is, I'm going to call it data frame original. So I just say PD. So remember, this is just referencing, we're using pandas as PD. So we're using the pandas library and we're actually going to read. Notice it prompts us with options. This is a CSV file. So I just arrow down until it says read CSV. And what goes in here? Well, the URL. Let's run this thing. So I hit shift and enter. So far, so good. I haven't broken anything. If I do, I'll show you what I do to fix things too. How are we doing? Is everyone with me thus far? So Matthew, yes. Nick, Matt, all right, nice. And you see the nice green check marks. Yes, it feels good to see the check marks, right? So far, so good. All right. Now, it's one thing to actually go load the data, but what's it look like? And actually, what is a data frame? Has anyone worked with this before and used data frames before? What's a data frame? It's okay if we don't know. And also we can use Python. This is Python, just like any other Python code we write. I can use Python's tools to take a peek at it. So I'm going to run this. What in the world is a data frame? Well, in this case, we see it's part of the pandas library. We got core, frame, data frame. So that's one thing, that it's a class inside of that particular library. But let's see what it represents. And we can do this. I could say print df. Remember, we're using just pretty typical Pythonic tools here. So type, we can use that in any type of Python variable. Print, we can print something out, and if it has the corresponding print method that's already set up, it'll just know how to print it out. Look at, we have essentially, it feels like a table. We have data like survived, P class, parents, children aboard, fare. It's not that great looking in this interface, but we could print it out. But guess what? In this particular tool, we don't have to do this. Whatever, if you just run a cell and it contains a variable, and that's the last call in the cell. Oh, look at that. In Colaboratory and other notebooks, you don't have to actually call print. Just make sure it's the last thing in the cell, just align with that particular variable, and it will display a very, look at this. This is actually HTML formatted. Look at the two versions. We have up above here, the print version. Doesn't even show all the columns. There's no bold up here for the column headings. Look at this. This is HTML. If you hover over something, there's an on hover effect. It's pretty. So we've already learned a lot about this particular notebook in terms of the capabilities. We've learned that we can use normal Python to do a lot of stuff, and we could even use, like, for instance, print, but it makes a lot of things easy and actually improves upon them. And it actually makes the display quite aesthetically pleasing. So is everyone with me so far? Any questions before we go on? As Matthew has said, does everyone have green check marks? We good? So, all right. Now, I'm going to, first and foremost, let's look at this data. We see this printout of it, essentially the pretty print version, if you want to call it, through Colaboratory, the notebook. I can actually use something. There are methods on this particular data frame class like head, and I can actually tell it how many rows I want to see. So head is what you think it would be. It's just the first 20 rows in this case, if I run this code. So here are the first 20 rows of this data frame. So notice survived. We could look at the key, but it looks like we'll play it safe. The survived is a 1, so if it's true, and a 0 if you didn't make it. P class, so the priority class, the passenger class. If you're flying first class, you know you get all the amenities. You've paid a lot of money and you get the good stuff. Third class, probably not where you would want to be. We have sex, so male or female. We have a binary listing there. We have siblings / spouses aboard. We have parents, children aboard, and we have affair. So we got a lot of good data. So far, so good. Actually, you know what? Pandas makes it, I wish I knew the mean and like I want the descriptive statistics here. What can I find out here? Well, guess what? It makes it pretty easy to get some basic data this way by using, again, the methods that are actually with this particular class, the standard data frame. Now, a few things though. Notice when I ran that, I have data on survived, I have data on the passenger class, I have data on the age. So again, you have a mean, standard deviation, the minimum, the maximum, and then by percentile. Notice sex doesn't appear. And we talked a little bit about this last week. Like, we get the meanings of male and female, not so helpful for the computer, not when we're going to be running analyses. Yes, Jessica, Jessica hit it right on the nose. We need numeric. That's exactly right. We need to translate this just like survived could have said yes or no. It didn't. It has numbers, and that actually works right out of the gate. However, sex is listed as male or female strings. And we need to change those strings to something that our computers can handle much more easily and actually run analyses on. So and Nick says this is the one if you're thinking the one hot encoding we talked about briefly. This one hot encoding is where we take a field that has several different, that was a good, you're right on, they're very similar, Nick. One hot encoding, we take a field, maybe it would be, for instance, if passenger class actually said first with the word first, second with the word second, and third with the word third, and they weren't ordinal, we might do it there. The idea is you'd have multiple values and you'd break all those out. In this case, we can just replace, essentially. In this case, we can say, hey, anything that says male, let's recode that and say whatever value, 0 or 1. And anything that says female, let's recode that accordingly. So first things first, I'm going to get a list of the columns that I actually want to keep moving forward for analyses, and I'm just making a list right here in Python, an array, whatever you want to call it. So survived, I'll use that. P class, I'll use that. What else do we have up here? I'm not going to keep the name field. I just can't see myself using that for what we're doing so far. I will keep sex though. I will keep age. You'll see why I'm making a list here in a second. It just makes it. So I will keep siblings, spouses, whoa. Board. I mean, for now, I'll keep parents, children, board, and I will keep fair. But notice not everything's in here. Anytime now, there are many different schools of thought, but the idea is when you're working with a data frame, don't actually mutate the data frame itself. What does it mean to mutate something? If you're talking from a computer science perspective. Yes, Matt and Jake, to actually alter the data. We don't want to actually keep changing data in this particular table right here, in this data frame. It's much better, generally speaking, to start a new data frame. And then I always know I can always come back to each version of the data frame and I can see what did I mess, you can compare and contrast and say, what did I mess up? If you actually try and make it so that it's mutable, what happens is it's very hard to know which step caused you issues. So you'll hear in the functional programming world, you should prefer immutability. And that's what we're going to embrace here. We're not going to just change this data frame over and over again. We're just going to be making new data frames. Now, there are memory issues, storage issues that could come up, but for our purpose, it's not an issue for this little data set. So let's just do this. I'm going to create a new data frame. What should we, well, I'll say new. But we'll call it number 1 because I'm going to have several different versions of this. Now, I can actually type in df orig, and the way it's set up, it's actually quite a beautiful syntax. If you use the array brackets on a particular item, it's set up behind the scenes so that you could actually do a few things. Actually, let's take a quick peek. We'll do this in a separate cell. So let me run because I want you to see a few things. This syntax is used so frequently. If I say df orig, and I actually put in one of the strings as the values here. So age, let's say. What happens? Let's see what happens. Well, it gives us a series, essentially. Instead of having this multi-dimensional array, we have a series. We just have all the ages if we actually put in age. Same thing if I put in df orig. Oh, P class is the next one I see over there. Same thing. But there's another form of the syntax we can use, and this can be very confusing. Let's actually, you'll see this. What if I pass in a list. And this time I say age, I'll use those same two for the purpose of example. And P class. Oh, notice it keeps, if we were to actually, I'm actually going to come back up to this cell instead of just I keep zooming down all the data here. I'm going to come back up to this cell and I'm going to say type. I'm going to call that on. Notice if you pass in a list, it passes back a data frame. But if you pass in let's see what the type is of this one, of age. If I just pass in the string, if you pass in just a string value, you get a series. This is a big deal. This is the source of many hours of confusion for people new to these types of notebooks where you're leveraging pandas to do some work with data. It's a beautifully powerful syntax, but it can catch you off guard the first few times you're using it or see things. So if you pass in a string, you just get that column and you now have a series. But if you pass in a list, you still have a data frame. You just have a data frame that only has those columns. Does everyone make sense? Does that make sense to everyone? So, all right, I see some thumbs up. I see Billy says yes. All right, just making sure. So, now, let's actually use the work I'd started up above. I'm going to create a new data frame, or we'll just call it new one. So this will be an updated version of the data frame, and I'm going to take the original and I'll pass in the columns I created up above. So I just get the data that I could actually use in analyses, or that I want to eventually end up using. I don't need name. So we now have the new version. And actually, I'm going to come back up here just so if I end on the line, so that's the last thing, it actually pretty prints out what that looks like. So notice the name column no longer there, but we still have that sex column. That's not going to work like that. That's not okay. So let's come up with a scheme to fix this. So let's do male. I just took, you could set them for whatever value you want. There's no, doesn't matter. This is just being, this is very arbitrary. I just quick put in these values. Now, we're going to end up using this, and I'll stick to the convention. Sometimes I use double. I'll try and keep my code consistent so it's not confusing. Now let's do, I'm going to create you could do this a few different ways. I'm going to create a new data frame. And I'm going to build it from df new one. And with the intention that I'm going to make one more update to it. Let's say df new to, let's have a column called sex binary. And let's have that be df new 1. We're going to grab the series that contains all the information for sex, and we're going to map those values to our male female map. Does this make sense? Generally, even if you haven't, the idea that we're just going to, when you map something in programming, you typically are saying, all right, if it's this value, then do this. If it's this value, something else. That's all we're doing here. I made a new data frame with the intention that I'd actually add a new column to it. Again, I'm just trying to make sure I always build up, and I could look back through my code to see where the issue happened in any particular data frame. So I'm going to run this. And actually, I'm going to, again, well, here, I won't rerun that. I'll actually run this in its own cell. And let's see what we have now. Ooh. Oh. That's nice. Oh. We have the makings here for some good stuff. Now, some quick things just to point out about Colaboratory, just to show you some of the power that you have here. There are little tools that you can use. Notice when I put in the 2 percentage signs, I can actually, there are several options that come up here. Let's just use one like time. I put that at the top of the cell. And now let's say I want to df new to, and I want to describe this. If I run this, look at the data we get. It actually tells us the time and the actual, we see system, it's broken down by user versus system, and then you have the total. That's all just built right into this tool, so you can easily benchmark something. For instance, maybe something is the bottleneck that's causing your code to run terribly slowly. You can cell by cell, you can figure out, hey, what's going on? Why is this not performing the way I want it to? And notice we've been building this up cell by cell. You don't have, like, I could be typing this all out and just adding code, and then eventually get to a point where I come up here to runtime. And you go ahead and try this. You just come up to runtime and notice I have options. I can restart the runtime. All your code is saved, but none of the state is present. Notice we don't have any of the check marks over here. The beautiful green check marks are gone. It's terrible. We can fix that though, right, Matthew? No. We can fix this though. We come up to runtime and we restarted it last time. Let's restart and run all. That's the option that if you feel like your state, for instance, you mess something up. For instance, let's say up here, I wanted to, you can import things anywhere, but I am pedantic in the sense that I like to do all of my imports at the beginning when I'm setting things up. And let's say I wanted to import more things. I'm the type of person where I would come back up here and I would import something new. And then I'm going to hit runtime, restart, and run all. And now it's going to rerun all of those cells. It doesn't take that long. It's running on really good equipment. It's already all done. So please try that if you haven't, just to see, just to check it out. And next, let's actually dig into this data a bit more. So before I head on though, any questions thus far? Has anyone already thought of great, you're thinking, oh my gosh, I will never look at data the same again. So just remember, with great power comes great responsibility. You're getting a little bit of power this way related to data. We'll talk about some of the ethical implications as we move forward in our club. So let's take a look at some of this data in ways that might not even make any sense, but I just want you to see we have options here. Remember, I imported biplot above, but we don't even need to do that. Nick, no, there's no problem. Let's, yours says broken at df new one equals df orig. Well, we can fix that. So let's just jump up here. Nick, let's just give it a try. And if not, I'll let you watch the recording, but let's just take a quick peek. So I have df orig here. And then I called some stuff, just playing around with it. I have the columns here. I'm wondering if you just have a typo in your columns. Yeah, Nick, that's what I would wonder. So what I would check is, are all of these typed? What I would do, here's the beauty of proofing something like this. We can fix this. Where do it's right here where I actually do that the first time. Here. I'm going to copy this code. Here's how I would troubleshoot that, Nick. Just come down. I'm going to runtime. I'm going to restart runtime so it doesn't keep any of my states. And here's how you can troubleshoot this. We're going to head down to that cell. We're going to create that columns stuff all in the same cell down here. So it doesn't matter if I read it. I can reassign the variable. There's no issue here in terms of Python. It's fine. What I would do is I would build it up variable by variable until it works. So for instance, I'm tossing this stuff off to the side in a comment. And I'm going to get rid of this. Let's try running just we can actually run up to the selected cell, I think. Let's see. So let's run before. That brings us, so if you clicked run before, that brings us all the way up to this particular cell. Then you just try running that cell with just say 2 of the variables or 1 of the variables actual string names for the columns there. That one worked, but let's say I typed in sex wrong. Let's say I actually said sax because I played saxophone in high school. Oh, look at the error I get. Does this help, Nick? If you build it up string by string, I think you can figure out which one you typed in incorrectly. My hunch is it's one of these. The siblings / spouses aboard, or parents / children aboard. They're easy to mistype. So I'm going to undo what I've done here, but I'm confident you can figure this out. That's all. These notebooks make it so great to troubleshoot stuff. Yes, and Nick, it says you use a lot of the same techniques when you're debugging other stuff. So now let's go back up here. I just put it the way I had it. Let's run everything again. So restart and run all. I love these notebooks. And ta-da. Yeah, it's a beautiful thing. Let's look at some graphing. And Nick, if you need anything, just let me know and we'll get you set up here. I'm just going to do some basic graphing stuff. Let's see here. How about let's plot something. And let's make it, notice it prompts us. We see the parameters that are associated with this particular call. I want the kind to be scatter. This doesn't make much sense in the big, I'm just doing a quick plot. The x-axis will be fair and the y-axis will be P class. Huh. Interesting. Look at this. So in terms of the passenger classes, now again, this graph, this is not I would not send this to Tufte. He's a famous researcher related to visual representations of data. Don't tell Tufte I did this. But I just want you to see there's some things we can do in terms of displaying the data. Look at the people who spent the most. This should make sense. We see are align more with the first class. The people who spent less are in second class, and the people who spent less in fares in terms of the maximum are in third class. That's not rocket science. That's not earth-shattering information. Let's see if we can do better. And I still wouldn't send this to Tufte though. So next one, how about group by, we're gonna send in a list and I want by P class. So the class of passengers, and I also want if they survived or not. And size, don't worry about understanding what's happening here. Just type in what I'm typing in on my screen and we'll talk about what we're getting. Don't worry about how we got there in this case. There's too much to cover just for. So if you can't see it that well, it's just def new to group by. And so we're grouping by P class and survived. And then we call size. Then we call unstack. And then finally we call plot with the kind equaling bar and stacked equaling true. Oh, now we're talking. Now look at, what does this tell us? If we look at this particular graphical display, what trend do you see here? Notice the numbers are sideways. I could have fixed that, but we're pressed on time. So 1, 2, and 3. So first class, second class, third class. And notice it has a legend up here for graph. What does this tell us?
Seems like not many of this, wait a minute. Would it be more of the third class survived, it looks like?
Well, survived, I think the 1 means you did, and the 0 means you didn't.
Okay, so a lot less people survived in the third class.
If you look at the
Obviously, there were
percentage,
a lot more people there too.
there were a lot more. So
Yeah.
Matthew, yes, you're hitting on several good insights. That's exactly right, Matthew. There are a lot more people in that class, but if you look at the percentage of who survived, it's a much smaller percentage of survivors in the third class than there are in, say, the first class. So that looks like that could be a reasonable predictor, right? If we're trying to guess, hey, who survived, who didn't, this is a reasonable predictor. This is something that we could say, hey, let's make sure we use the passenger class. Does that make sense, everyone? Are we on the same page so far? So, all right, I see several thumbs up. Cool. Just making sure. So let's keep going. This is good stuff. So we see that we can graph things and take a peek. And you can do it for other things too. I was going to put in I can, let's take time for one more. New to, let's do sex. So now, if we want to diagram this, we can actually use, like for graphing purposes, we don't have to actually use the numerical value, the 0 or the 1. In this case, we can actually just use the standard series sex that contained male and female strings. That's okay, because we're just graphing here. We're not actually running analyses. So we'll do that because it'll actually label it for us when we're done, and I won't have to. Notice this is just like the other. There are other graphs we'll use in the future, but the thought was, oh, more data that seems like it could shed light if we were trying to make guesses if a person survived or not. It probably was better to be of the sex female than it was male for this particular voyage, because we can see the percentage of females that survived much greater than the percentage of males that survived. Now, there are other graphs we can do. I'll do one last one, and then we'll actually jump to an analysis where we actually try and predict things. Oh, how about let's do age. Now this is going to look very muddied because there's just too many ages, and I could have aggregated this in some way, which just means join some of them together. And Yeah, let's just do that. Whoops, and look, invalid syntax. I finally did it. Oh, well, when you're old and typing fast, letters sneak up on you. So this just, it does convey some information, but I would certainly redo this graph. But we see if we were looking for a trend of just by age, what does that tell us if someone survived or not? Well, if we look at this category right here, we can see if you're in this region of this, and I'd have to make that bigger so you could actually see it. We don't have a lot of time, so I'm not going to do that. But you can see if you're in this area, a lot more died than survived. And so again, there's the potential that we could create a model, a classifier, which really does a reasonable job predicting if you survived or not. So here's the good stuff. Let's get to analyzing some things. First things first, do we actually have any missing values? Because if we do, that's going to cause us some issue. The good news is we're not missing any values. I purposely chose an easy data set this way. The truth of the matter is you will spend most of your time working with engineering, cleaning the data on any good type of artificial intelligence, machine learning, deep, whatever you're doing, your time with the data will be the most important and usually the most extensive component of your work. That's just how it goes. In this case, we didn't cheat. We just cherry picked. We chose really good data in the sense that we have all the values. We only have a little bit of work to change one of the columns to numerical, and we can just roll with it. So we're in good shape. Does this make sense? Do you understand why we want to check for this? Because if you're missing values, then you'd have to say, well, what do we do with those missing values? Our model's going to have some issues when it gets to those. But in this case, you can see we didn't have any nulls in there. And this is a pretty clean data set, intentionally so. So it looks like no questions related to that. Let's actually jump into something. So let's set up a list of features that we actually think are worth exploring in terms of the analysis. So sex binary, that one's all set to go. It's numerical, and it looks like from the graphs we saw that could actually be predictive. P class, yes, that looks interesting. Age, and let's toss in one more, parents / children. Aboard, I think is. So let's use these particular columns. Let's run some analyses using these particular features. And the convention is, you'll see at least many people online when you're looking at other notebooks, capital X, we'll talk about why later. We tend to, when we're gathering our features together in a data frame that we're actually going to run the analyses on, we call them X. And so we want df new, but in this case, we're just going to store the features that we're interested in. And Y is lowercase because it's just one, it's a series. A series just means one column of values. it's essentially an array. And in this case, we're just going to look at df new to how do I get a series? If I want the survived, what do I pass in here? If I want to just grab the survived column.
A string, correct?
Yeah, Billy's got it. We just use the string. If I passed in a list, I could pass this in, even if it's just for one item. If I passed in a list that contains survive, it would be a data frame of one column. But we want a series in this case, and we just pass in the string. And so let's run that. Make sure I don't have any issues. Okay, so far so good. Because let's be honest, you were betting I had a typo in there the way I've been going. Now, we haven't talked a lot about this yet, but we will in future sessions. Typically, you want to break your data up into training data. That's where you build up your model, your classifier, and then you want to test it and say, hey, here's some data I set aside. Let's see how well we did in terms of developing a particular model or classifier. Well, you could build your own code. Actually, in graduate school, they made us build all this stuff from scratch. And that was not pleasant. I'm not going to be that way to you. We don't have to build our own stuff. We can actually use tools that are already available right through scikit-learn. So train, test, split does this work for us in a way where randomly it just says, hey, you want to split your data up into X features for training, and then X features for testing, and then Y series for training, and then a Y series for testing. Essentially, I just want to make sure we're understanding this. Let me share my screen for a second here. I'm actually going to use my iPad. So I'm going to stop sharing for a second. I'm going to share, but I will share my iPad instead. Just so we conceptually understand what's going on, because now, can you see my iPad screen okay? Yes. All right, cool.
Yeah.
All right. Well, just briefly, I know we're almost done with our session. Let me slide this microphone over towards me more. There we go. We've got several rows in our data. Let me take that a terrible color to start with. There we go. And row 1, row 2, row 3, row 4, row 5, row 6. All of these rows made up of all of our features. For this particular, we have sex. I'll just put an S up there. We have P class. I'll just put C for class. And so on. And eventually we have the survived. I'll put SU for survived. So what this tool allows us to do is to say, well, I'm going to take this first row. I'm going to take these features, whatever they are. They're going to go into training. So I'm building up a training set here. And we're going to have a test set also. And I'm going to take this This is training in terms of the X, so I'll put X here, and this is testing in terms of X. But I've also got the result. I've got did the person survive or not? That's going to head over here into training. That's the result, the Y. That's what we're going to actually use for our supervised. This is supervised learning, as we've talked about before. The idea that we know the answers for a lot of this. And so we're going to help this classifier along by saying, hey, I know the result. In this case, this person did survive. And their sex was male, and their class was first, etc. All of this information from that row 1 heads down to the training set randomly. And all of this information heads over to the training set for Y also. However, for this next person, row 2, I'm going to say, gosh, you're going to get assigned to the test. Row 3, you get assigned to training. Row 4, you get assigned to test. And then the rest, like several more, get assigned to training. We need more in training typically than we need in, we want to use the data to make our model as good as it can be. So I'm going to move this. So the idea is we've got all this training data. Let's split it up. And let's say 70% is for training. And we set aside 30% to actually test it once we've built it up. So we're going to build our model over here using 70%. Here's my model or classifier, we could call it also. Then that 30% that'll be the test. That's where we get to say, okay, did this work? And we're going to predict those 30% and say, all right, knowing your passenger class, knowing your sex, knowing all of these features, what is my prediction? And we can actually see how well we do. So that's what's going on here. So let's see what we can do and finish this up. We're almost done. I promise. It's cool to see the final product. So let's finish setting this up. I'm going to quick type in some stuff here. We're just going to use this tool, train test, split. This does all this work for us. I pass in our data frame of features. I pass in the value that we're going to be predicting. In this case, did you survive or not? Test, size, just as I said, we'll keep it at 30%. I'm just passing in a random state so I could show you this later, but for now, don't worry about this. And oh, did I actually not? One sec, I didn't actually get that imported the way I need to. We'll just rerun the whole thing. Wait, from import. So sorry, see, professors, that's why I love this tool. It's very accommodating of people who make mistakes all the time. Restart run all. I forgot to include our train test split. library. So this time we can make it work. It did, because it actually knows what it's supposed to be doing. Now let's actually use this data to build a classifier. So that's what CLF is going to stand for here. We've got our decision tree classifier. I'm going to set something called max depth. Don't worry about it for now. There are certain tricks we can use to help train our decision trees. And a decision tree is something we're going to cover in much more detail. But the beautiful thing about a decision tree is we can actually see it. And when we see it, it will actually it'll help tell us what's happening. It makes sense. And once we built our classifier, we're going to try we're going to use it, and then we're actually going to get a value that tells us how well it did. So trust me, it'll all be worth it in just the next couple cells. So we're almost done, 1226. If we want to see the accuracy, I can just say print accuracy, and then I'm going to have metrics.accuracy score. Actually, I don't want balanced. I just want accuracy score. And Y test, Y predicted. So basically, it's just saying how well did we do if we built up this classifier and actually make these predictions. Our accuracy score, if we're using our metrics, is 0.7752. We'll talk more about what these scores mean, but the higher the better. Think about it. We built a model that predicts very well whether you're going to survive or not, just using this data. And let's see how it's working. Because like, as I noted, we haven't really talked about how decision trees work. The beautiful thing is we can see how they work. I'm just putting in some values so we can actually see what's going on, because it's a very... All right, tell me when you've got that cell entered, because once I hit enter on this, it's going to be a big diagram. But when we hit enter on this, we're going to see the fruits of our labor. It's going to be a beautiful thing. So, how are we doing?
I'm ready.
All right. I hear the excitement. Here we go. I'm going to hit enter. Let's see if this works. Whoa. All right. Here's our decision tree. This is a model we built in just this little bit of code. And we trained it with 70% of the data randomly. We just selected, like I said, we took rows and said, you're going to be in training, you're going to be in testing, you're going to be in training, you're going to be in training. And then we just run this code and it builds a decision tree where it says, hey, what is the first thing we should ask? In this case, it came up with the decision. All right, First, are you sex male or female? That's the first question. If you are, then it makes a decision accordingly one way. And if you aren't, you move to the next node. Next on this side, we need to know what your passenger class was. And then once we know your passenger class, we need to know what age were you? Were you less than 2.5 or were you greater than? Here we have parents, children aboard. It just works its way down after generating a classifier. It just asks a series of questions, essentially. You can use this same tool. I love decision trees because they make sense. You can build a neural network and you have no idea why things are being classified the way they are. A decision tree is a beautiful, wonderful model which actually shows you exactly how it's making its decisions. So you can use this for political questions. You're trying to say, what will this person vote? You can put in the data and make predictions this way. You can use it for any number of things where you're just wanting to know, especially a binary value here. We can use it in other instances too, but it really is great for classification, simple classification here. Yes, Matt, this is what it came up with. This diagram represents the best model it could make in terms of the data, the features that we fed in. Awesome. It's good stuff. If you can't tell, I think this is such a fun thing to do. And we did all this in essentially 1 hour. I'm sorry I squeezed in so much, but we recorded this. I'm going to post this to our YouTube channel, and you'll be able to go back and watch this just in case you had issues along the way. Hopefully you can just pause the video and get it figured out. Any questions before we go? Because it's 12:32. Oh, and James, I'll email it out, but here, let's, here's the channel. That's a good point. Your wisdom is very helpful to the group. So there's the link. I'll be posting the video later. You can then work through this again. And hopefully this helps us along our path as we get started with more and more machine learning related work in the AI realm. So thank you everyone for sticking around. I know we covered a ton of stuff and it was fast, and I know it could have been done much better on my part, I'm sure, but this is fun stuff. So I'm going to stop sharing. I'm going to stop recording. It was good to see you all. Yes, we'll see each other next week. Have a good one.